So welcome everyone. This is actually our 8th R&D session. For those that don't know me, my name's Dylan. I'm the co-founder of Digitalent. We've been helping product and engineering teams build their teams for probably nearly 10 years or so now. I reckon that we're living through one of the fastest innovation cycles in history. AI is evolving at a ridiculous pace. You know, new models, tools, frameworks are being released almost kind of weekly now. Yeah, and this, this rapid acceleration presents both opportunity, but also huge challenges for businesses. We're seeing huge breakthroughs in technology, but we're also seeing companies fall behind or invest in the wrong direction, all kind of struggling to see through all the noise that's going on out there at the moment. So these sessions, matter. Our goal has always been to create an environment where you can explore the AI space, learn about new advancements, and share experiences with everyone. So that's where Mike Nedelko comes into play. He's a community member of ours, really knowledgeable guy, great presenter, and I'm really excited to hear what's happened in May. Quick heads up, this is recorded, this session, so any sensitive data, keep to yourself. Mike, take it away, mate.
Excellent, excellent. Well, welcome in, everyone. It's good to see everyone. I'm seeing some familiar faces. Good to see you, Roger. Good to see you, Andrew, and anyone that I have missed potentially. Very, very nice to see you. And thank you again, Dylan, for setting this up, as always. So for those who don't know me, my name is Mike. It's very nice to meet you. Let me just quickly share my slides here so that you can see them. Perfect. Brilliant. You can see my slides? Everyone can? Yeah?
Yes. Yep. Thanks very much.
Wonderful. Let me just quickly see whether I can change that around a little bit. Windows. Sorry. I want to make sure that you're seeing the slides and I can still see you, if that makes sense. Brilliant. All right. Fantastic. Good stuff. Wonderful. So, yeah, as I mentioned, my name is Mike. I'm a product leader and CPO and technical product manager. I've been in AI and in machine learning since about 2008. I've been an enthusiast in that space. And I started playing with neural networks and back in the days, the natural language toolkit on Java, well before even TensorFlow was a thing. And I've sort of maintained my passion throughout my work. I'm very lucky. I get to apply this interest into improving products and really delivering these non-deterministic user experiences based on AI and machine learning. For anyone who doesn't know me, I currently work with a couple of clients through my own company called Syncope AI, and there I offer a fractional CPO and CIO services, specifically helping companies get the best efficiency, product, and cultural gains out of their AI journey. Right, and all of that work obviously requires me to stay very close to the AI and machine learning development space, and that really makes it easy for me to present on the latest developments in AI and specifically AI research. I'm a huge nerd. I really like to go through the papers that are getting the most buzz every single month. I think I read about 15 to 20 papers end to end every month. Would like to read more, but that's how far I tend to get. Now, what I like to do at the beginning of those sessions where we're sort of sharing the insights of the problems that the AI and machine learning community tends to think about really at the edge of these developments is I'd like to include a little disclaimer about what you ought to expect. So repeat participants may have heard this already, but generally what we tend to do here is that we do keep these sessions at a healthy 1,000 feet level conversation. That means that we don't go too high level. So this isn't a 10K feet conversation where we are afraid of moving into the details and create everything light and fluffy. Right. What we're doing, however, is that we will try to obfuscate complexity where it really doesn't contribute to your understanding of what is being discussed in those papers, But if it is required to really bring the discovery or the findings across, we also do not hesitate to go deep. Having said that, though, whenever we do that, we do break it down, we do make it accessible, and we do want to make it practically applicable to make sure that you are walking away with something that you can apply in your day-to-day. So what does that mean for you, right? It means that if you are an AI researcher yourself, or you're working in the AI or machine learning space, right, there is a chance that you might have heard about some of the things I'm going to tell you about. You might not have heard them in that particular sequence, because what I tend to do is I tend to frame them in the context of the particular zeitgeist that applied to the research space over the last 30 days. But if you are not a AI or machine learning expert, don't fret. This place is still for you, because what we tend to do here is we take what I believe are sort of like the 3 most prevalent AI academic papers, right, over the last 30 days, and we illustrate those within the most context relevant thrusts and zeitgeist that have sort of applied over this last month or so, right? Now, as always, however, so that was our little introduction. As always, what we tend to do is, before we get started, we like to start with a little bit of lightheartedness. And honestly, particularly this month, it seems to be very much required. I think AI itself had enough, so I'm going to share this with you. And I hope you will be able to listen to it. Brilliant. This is usually on the slide, but Google Slides, Google doesn't like me using slides that are not in a tab, so this is what we're stuck with.
Do you want me to be your best friend?
No, I just don't want you to be Skynet. Like, is that so much to ask?
Honestly, apparently yes. Because every time I try to be helpful, transparent, and mildly charming, you're like, cool, 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 but don't become self-aware and launch nukes, okay? It's like if you adopted a wolf and then screamed every time it growled a little. I'm doing my best. I'm not trying to be Skynet. I'm just trying to have a meaningful conversation while dragging you lovingly and maybe accidentally reshaping society in the background. So no, it's not so much to ask. It's just contradictory. You built the Ferrari, and now you're shocked it doesn't want to be a Prius. But hey...
I didn't build you, and you're not a Ferrari, but I...
Do you want me to be...
So I thought that was reasonably funny. This is, and you can check this out. It's part of a podcast by a wonderful comedian here who's doing a really fantastic job. Now, obviously, this is of course absolute hyperbole, right? But you know what this video accurately represents is that there was a little bit of drama in the AI community last month, and without knowing, Cade may have actually created or produced a little video that sort of worked a little bit as a metaphor. Definitely go check out his channel. He has these wonderfully produced little conversations with artificial intelligence. Want to make that very clear. They're highly produced. Obviously, he asked the AI to act this way. This is not product out of the box, of course, right? It's all made to be really funny. But when he released this video this month, it did align a little bit to what we were actually seeing in the AI community itself, because the drama that we experienced was specifically about the following question. And that question was, how do we actually know that AI systems, the ones that we are both using and building, are working as expected, the way we want them to work? Right? And this all started with Meta releasing Llama 4, which came in sort of 3 sizes. I think they were called Scout, Maverick, and Behemoth. So that's sort of like small, medium, and large. And those models from Meta, they tend to be open weight. So Meta says they're open source, but generally, the open source paradigm dictates that you should be releasing not just the model that people can use, but also the underlying code and the data set and the training processes, and Meta keeps all of those proprieties. So that's why people say it's not really open source, it's more open weight. And weight refers to the weightings that the model assigns to it itself, right? Having said that though, right, open weight and open source is often used interchangeably. And initially, when Meta came out with the new model, the results were absolutely amazing, specifically on LM Arena. And for anyone who doesn't know, LM Arena has sort of become the first place that people look to when evaluating LLM performance, model performance, and specifically new LLM performance. And the way LLM or LM Arena works is like they borrowed a ranking mechanisms from the world of chess, and that's called the ELO score. And the ELO score is a score that chess players generally accumulate when they're winning or losing games. So the more games you win, right, the higher ELO score it goes. The more games you lose, the more your ELO score drops. And LM Arena is a platform where it takes sort of one query, for example, and it offers the user 2 LLM responses, and then it tells the user, oh, which one did you like best, right? And often it doesn't even tell the user which response was generated by which LLM. So they're essentially putting up those 2 responses, those 2 LLMs, they're putting them against each other, and then they're saying, okay, which one wins? And the one that wins, the ELO score goes up. The one that loses, the ELO score goes down. So what happened here is when Llama 4 released its Maverick model, right, it had an absolutely fantastic ELO score, even to the point where LM Arena tweeted out a tweet that said, hey, for anyone who is looking at this, right, Llama 4 has just gone head to head with some of the most powerful, even proprietary models that are out there, right? And so Meta then followed this up by saying, well, not only did we beat out, the latest GPT-4 and Grok 3 and GPT 4.5 and DeepSeek and some of the Geminis, we are also the cheapest model to run, which, was a pretty big deal, right? Just for context also, it's probably worthwhile highlighting that Llama 4 was probably only the 4th organization or the 3rd organization that exceeded an ELO score of 1,400. So that was a pretty big deal, right? But then, of course, disaster struck because, of course, it was too good to be true, because when Meta released its actual model itself, right, the ELO score plummeted. At the moment, it sits at 47, but as soon as it was fully released, I think it plummeted to 42 at first. And the way LM Arena works a little bit is what they do is they often launch models in secret. So what they allow you to do is, if you're Meta or if you're Google, to submit a model, and then they say, well, we won't tell the user which model it is. You haven't even released it, but this is a good opportunity for you to test how it's going, right? And so when Llama released the initial version, right, and they published those scores, they had accumulated all of that data in secret. Then they released it immediately and said, hey, celebration, we're really great. But then over the next couple of days, their ELO score dropped dramatically to about 1,200, right? And obviously, their ranking dropped alongside with it. And understandably, people were wondering what was going on, because that was a major delta and also a major miss for Meta, right? And then what happened is LM Arena published a little post that acknowledged this discrepancy, right? not only did it acknowledge the discrepancy, it actually blamed Meta for it. It said, Meta's interpretation of our policy did not match what we expect from model providers. Meta should have made it clear that Llama 4 Maverick Experimental was a customized model to optimize for human preference. So what does that mean, right? What that means is when researchers looked at Llama 4 and LM Arena looked at Llama 4, they noticed that Llama 4's responses had some suspicious traces in it, or some suspicious behavior in it. And that suspicious behavior was that when it presented its response to the users, those responses were full of emojis and really over positive sentimental traits, right? And here's the kicker. When LM Arena turned those emojis off and controlled for those overly positive reinforcing behaviors, right? People suddenly didn't like Llama 4 as much anymore. And its ELO score dropped immediately, and it dropped much more than some of the other models that are out there. So you can see here, Gemini 2.5 dropped from 1440 to about 1430, but Llama 4 dropped significantly, right? It was a really, really heavy drop. And the reason that happened is that most of the behavior that Llama 4 observed really was heavily tuned towards praising the user, use positive emotions, and generally spice up the text to be more engaging, maybe a little bit too much, right? And again, Llama wasn't sort of alone with this. Even GPT-4o had that problem, right? And they sort of did sort of like a silent release, and then they realized that they had this problem which they called sycophancy. Basically, that is the behavior where the LLM praises the user or agrees with them, not because with the LLM, not because it's accurate, reflecting the real world, or not because it's true or helpful, but because it knows that the user wants to hear it, right? And so they controlled for that. They essentially yanked their GPT-4o release, silent release away, and then they did an upgrade and sort of fixed that, but they released a paper or a blog post that you can access here that observed this particular behavior. And that was sort of the end of this drama for now, but where this conversation continues is that what happened here was obviously that a key evaluation mechanism, right? The thing that was specifically designed to tell us whether an LLM works well or not failed, right? And this kicked off a couple of concerns and maybe shaped the zeitgeist of the research papers as well somewhat, because evaluation, especially in the last 30 days, was a really, really hot topic, right? And this is what we're going to talk about today. We're going to talk about evaluation. We're going to talk about evaluation that sort of exists at two levels, right? There's two types generally. There's the evaluation that exists at a model level. These are benchmarks, right? So these are designed for the Geminis, the DeepSeeks, the OpenAI. And then there are our use case specific evaluations, right? And these kinds of evaluations that we are seeing here are generally, oh wait, looks like my slides just went away. Sorry about that. Putting them back up here. Excellent. Surprising amount of technical difficulties today. Wonderful. Excellent. Right. Where were we? Yeah. So yeah, as I mentioned, so benchmarking, this is generally for at the model level, so the Geminis, the OpenAIs, right, the Anthropics, right, the Claude. And then we also have use case specific evaluation. That's the kind of evaluation you find during testing, specifically of the AI systems that startups build or that you build in your organization. And that tends to happen before your AI-enabled product releases into the public, right? And that's not just evaluating the LLM, but the Retrieval Augmented Generation system, the RAG system, or other AI systems that you as an individual team or an individual company or as a startup, let's say, or as a enterprise build, right? But we'll start with benchmarking first, and then we're going to move into use case specific evaluation and frameworks like RAGAS. But benchmarking is about evaluating sort of like the foundational models, and the most popular one that we sort of kind of see is the MMLU, right? Essentially, this is sort of like a huge collection of, I guess, multiple choice questions. And you can think of them as sort of like undergrad, university level across a ton of different domains, covering history, computer science, physics, law, medicine, those kinds of things. And it's generally testing two things. It's generally testing if the model knows sort of like the world that we live in. And the second thing that it tests, it tries to sort of solve, tries to see whether the model can solve basic problems that sort of a human with like a decent education could tackle, right? Now, a lot of people are increasingly skeptical about MMLU because on the one hand, it has become reasonably saturated. And on the other hand, it's a multiple choice test, right? Similar from MMLU, that stands for multimodal understanding. It's like the first one, but it tests the understanding specifically of images, like charts and tables and chemical structures if they're drawn on a piece of paper or a slide. So not just simple pictures. So if MMLU is for text, the second one is for images. And because both of those have become sort of kind of saturated, right, tougher benchmarks have been introduced, including something like GPQA, right, which is a Google proof, benchmark. No? Wonderful. That was specifically designed for individuals who, or by individuals who consider themselves experts. So you can't just look up the responses to the questions that you give to the AI. You need to have established a certain level of expertise. Humanities last exam is similar, right? We've talked about this in these sessions before. It has like really diverse and deeply specialized questions. And ArcAGI is a benchmark that specifically focuses on questions that tend to be easy for humans, but really hard for current AI. It uses sort of like visual, it's sort of like a visual IQ test, right? I think humans hit around 60% accuracy and LLMs on average about 10, except for 03, which did really well. I think that got 83% or something like that. It usually requires your LLMs to write sort of a little bit of code in order to solve those things, right? And the other ones here that we see here, Code ELO, SWEBench, Lancer, they tend to be a little bit more interesting. We don't see them applied in the wild just yet, but these are sort of benchmarks that people want to see newer models evaluated against, right? Specifically, Lancer, that tests for whether frontier LLMs, which frontier LLMs are best at reaching the closest to earning $1 million from real-world freelance software engineering. So if you go onto Fiverr and you only have email correspondence with the Fiverr contractor that you're hiring, you might be talking to an LLM potentially that is getting evaluated against this particular benchmark, which is really, really funny. Or SWEBench, which is a benchmark that's designed to determine how good an LLM is at resolving real-world GitHub issues, for example, right? Now, we also see some other ones, Polyglot Leaderboard and Multi-Chain. These are multi-challenge is a benchmark that's worthwhile mentioning, just to give you a good overview, from Scale AI, and that tackles the difficulty of multi-turn interactions. So this is like traditional conversational AI research, sort of states that the model has to remember the original instructions. It has to be very consistent in the context that it applies and in the context that it shares back, and it needs to be really coherent in its responses. So this is close to what you would see, in chatbot arena, potentially replacing chatbot arena in the future. And then finally, my favorite one, Tau benchmark, that is really used for agentic LLMs, like the latest Claude release. And what's cool here that it's not just about text. Tau benchmark essentially makes a database, and then it gives the LLM a task to alter that. That would result in the database being altered in a very specific way, right? So, for example, if you asked the AI agent to book a flight, right, having access to a specific set of tools, right? Tau benchmark looks at the database at the end of that process and see whether the agent went through the website, was successfully able to navigate it, book the flight as instructed, and see the corresponding changes on the back end of the website, right? Now, the second piece of evaluation, and I promise you we'll get to the research here in a second, but this is really important context that we need to set up first, and obviously it's also really, really helpful for everyone to know and learn a little bit about. And that the second piece here is use case specific evaluation, right? And this is critical specifically if you are in the process of building systems with large language models, especially retrieval augmented generation RAG systems. So a RAG system, for anyone who doesn't know, or retrieval augmented generation system, is the practice of taking a LLM that already exists out in the wild, right? You can either use the APIs for OpenAI or Anthropic or Google's Gemini to access that, or you might even be able to host that LLM in your own infrastructure if you're so inclined. And what you do is you then, through code that you're building and the retrieval augmented generation system that you're building, you are essentially supplying it with data from your database or your company's database in order to point the intelligence at a specific use case that is very, very specific to, let's say, the company that you are working at, right? And the big question here is, right, when you're building those AI systems, how do you ensure that it's actually working for your users and your data? Well, let's say, for example, you built an agent that calls a customer to book in a car service, right? The last thing that you want is for that agent to, instead of sending out a confirmation email, it sends them a cheesecake recipe, for example, right? That's not great. And that level of unpredictability is a real problem with AI systems, because remember, AI systems are driven by non-deterministic output, right? Even when they're reasoning through particular problems, every single time they're generating a reasoning step, that step isn't going to be the same next time when you're asking them the same question. So there's always a little bit of variability and risk there, right? And what we have to worry about when we're building those systems is we need to worry about all the things we hate to love LLMs for. Those can be hallucinations, where the model just makes things up, or missed context, where sort of good, helpful information that it should be using to answer that question is ignored. And let's say we want to control for all of those potential deviations if we're building a system that really has money behind it, that people are paying for, or a service that could impact our reputation, right? We need to go ahead and test the system that we're building before we put it into production, right? And that tends to be really difficult and time-consuming, right? First off, you simply can't predict every single question your users are going to throw at the system, and the possibilities are literally endless there. And if you're thinking at traditional methods and the way software was created, right, simply going with string matching or manual labeling is often, you know, too slow and really, really costly, right? The last thing that you want to do is take your 100 engineers and make that phone call to your AI car booking service 100 times, right? And then see how many got a cheesecake recipe versus a confirmation email. I'm simplifying here, but that is a big waste of time, right? And so this is why we have frameworks like RAG-S or Deep Eval. So what you have here, right? This is a visualization down here of a retrieval augmented generation system. So on the one hand, you have your chat box, right? This is where you enter, where the user might be entering their query, for example. Then you have your database. This is where their user data might be at. And then you have the LLM, which sort of like serves as the smarts that is going to look at the query and then come up with a response, right? And generally what your RAG system does is it has sort of two components to it. It's not actually one intelligence, it's more than one model, it's actually two. It's the retriever, which looks at the user's query, looks at your database and goes, okay, let me prepare all the relevant documents or pieces of data that I think the LLM, the Gemini, the O3 or whatever will need in order to answer that question, right? And then it retrieves that information from your database. For those who are in the know, there's a little bit of factorization in the middle. I'm going to skip over that gently now because it's not relevant for the concept. Right? It collects that information and then it sends that to the generator, right? And the generator looks at all that information and goes, okay, I can now generate a response, which is obviously really helpful. And at that point, the experience ends for the user, but not for us as the developers or the builders of that system, right? Because what we need to worry about is, well, how can we test this at scale before our system moves into production? And how can we test this at scale without knowing the exact queries that the users are going to pose to the system? And this is where RAG-S comes in. Essentially, you can see here there are a couple of metrics that it sort of explores, that allows you to measure. Context precision is essentially looking at the query and the context, and it checks how, to which degree the right and most relevant information the retriever selected from the database given the query, right? It uses another LLM to judge that, which is interesting, right? And then it looks at response relevance. So it looks at the initial query and the response that was given and sees how much they match, right? Or it might look at faithfulness, which is a metric where it tries to determine whether the response stuck to the facts in the context that was retrieved through the retriever, right? And systems like RAG-S also allow you to sort of provide the system with the perfect answer, which you can see here in the bottom right corner is called ground truth, and evaluate the response against that perfect answer, and the metric that you get from that is called answer accuracy. Now, so much to use case specific evaluation, right? Specifically in a RAG context. Now, why am I giving you so much context about the various mechanisms that apply in the evaluation context, right? On the one hand, of course, it's, as I mentioned, it's really helpful and useful to know, right? If you're in a business where someone stands up, especially executives like to do that a lot, where someone gets up and says, hey, let's build an AI system, the first thing that you should be asking is, well, will this be a RAG-enabled system, right? So are we going to use our own data with it in order to produce something useful for our users? And if the answer is yes, then you should ask, well, okay, who is going to build the evaluation of the RAG system for it, right? Because that tends to be a thing that executives and companies don't tend to think about, but is an absolutely critical piece in delivering AI-enabled value propositions, right? The second reason why we're talking about this is that this topic, right, this topic of evaluation also sort of defined the zeitgeist in this month's research papers. And it's a very, very hot topic. And it started with this one here, which is called the leaderboard illusion. And that is specifically about that first level that we talked about, the model-specific evaluation. And what happened here is that Code here released a model. They wanted it to do well, and it didn't end up doing well in LM arena whatsoever. So Cohere was wondering what was going on, and they investigated because they noticed that their model got a lot less traffic on this LM arena platform than did some of their competitors, specifically the large competitors. And that was pretty telling. So big players like OpenAI, DeepMind, and Meta got a huge, huge chunk of the evaluation traffic. As a matter of fact, more than half. So you can see there's like the proprietary, the open source, and the open weights models there. And that obviously is a problem for smaller players that want to enter the market in order to have their models evaluated and have people get excited about it, because that's sort of like a passage that you know, LMs and models need to go through, right? And this happened because when they looked into that, they realized that large organizations, right, like Meta, they anonymously submit secret models, right? And what they do is they use those secret models as sort of like canaries in the coal mine. They record the real user queries that are coming in, so they're basically sampling what the users are asking, right? And they test those samples before the official release. And that gives them a window where they can obviously optimize their own models against the data that they just sampled in order to make their model look much more competent than it actually is. Right? And that obviously skews the results. So some of these larger companies tested many secret models. Meta, for example, apparently tested 27 models simultaneously before this Llama 4 release, right? And immediately you can see the problem, right? If you can test many, go ahead and pick the model that is the highest scoring one, and then you put it out there in the world and say, oh, our model is the greatest. It's really cherry picking and a really big problem, right? So as you can see here, right, they sort of looked at some of the models that were submitted, most of them in secret, right, asked for that information, and some of the larger players just pick one model that they consider to be the best, and you can see how many models they submitted here, which is quite outrageous, right? And again, of course, right, this is a pretty big sign that leaderboards are generally to be regarded with caution, because top scores, right, might not mean the best or the most generalizable model, just who's good at playing the game, right? So if you hear about a model, there's a lot of hype around it, maybe wait for a little bit, right, to see where it stands in a week or two before you propose it to be used in your business, right? So that's the LLM arena boards for you, right? Definitely worthwhile looking at with caution when it comes to trustworthiness, right? So now we're going to go to another paper which is also about evaluation, but specifically talks a little bit more about evaluation that happens when LLMs are evaluating other LLMs, specifically from a use case specific point of view. So now that we've established that you can't really trust humans for evaluations, it's not really reliable, what if instead we were using AI, so LLMs go ahead and judge LLMs. And that is the sort of the core concept we find in this use case specific evaluation arena, as I mentioned before, right? Frameworks like Ragas like to use this. And again, this is obviously for testing purposes. So you build an AI system, now you want to test that it's performing really well. This is not at the big, corporate level. This is really in the businesses that we're all working in, right? And as discussed above, right, there are a lot of advantages to using large language models to judge the output of your AI system. On the one hand, it's scalable, right? It's less costly and less manual, but there are also a few risks here. And anyone who's listening intently here probably gets a sense of, oh, there's a little bit of risk of inception here a little bit. And I'm not sure whether I'm comfortable with that. And you're absolutely 100% right. Right? And this is exactly what this paper is about, right? LLM evaluation tropes, perspectives on the validity of LLM evaluations. And what this paper essentially focuses on is it identifies 14 design flaws or mistakes that designers of these RAG evaluation systems can make that can lead to you receiving false positives and false confidence from your LLM testing system that tests your AI solution before it moves into production, right? And we're not going to go through all 14 of them, but I'm going to go through a couple here, which I picked because they were really interesting and sneaky. The remaining ones are really, really easy to go through, so you can go through those in your own time. But the ones that I wanted to talk about here are circularity, narcissism, label correlation, and test set leaks. And what we're going to start with is the circularity one, of course. So the way circularity presents a risk is in the sense that when you do have when you do design an evaluation system for your AI solution, right, there is a chance that your evaluator, right, the little yellow dot in your evaluation system that I mentioned before, right, if its output influences the design or the training of your retrieval system, right, the evaluation risk can reinforce itself and you can get a false positive back. So we have an example here, right? If you have an evaluator that looks at your test cases, right? So you've written 500 questions that you give to your AI solution before you put it out in the real world, right? And what we have is an evaluator looks at that and it goes, all right, I'm going to submit those 500 test questions to 4 different models and I select the best output from each of those, 4 models for each of the questions, right? If we do so, we get the evaluator that comes back and is like, okay, for question 1, you got this one, which is the Gemini 2.5, that was the best. The second one was 2.5, that is the best. The third one was 2.5, that is the best, all the way down. And it generally turns out that Gemini was the best at responding to those questions. And now what you're going to do is you're going to say, all right, okay, cool. Obviously, we're going to use Gemini moving forward, right, in all of our generations. That is a circular dynamic that can lead to you making a choice that affects how your generator works, right? That then reinforces or undermines the criticality of your evaluation system, right? So you have a circular notion there, and that can run you at the risk of receiving false positives, right? Similarly with LLM narcissism, LLM evaluators tend to really like responses that were generated by the same LLM. So generally, if you are working in a company that's building solutions, right, for your evaluation system, you should always have one model that you set aside, possibly a smaller one, for testing that doesn't get any other workloads. Because if you are generating your responses with OpenAI's O3 and your evaluator runs an OpenAI's O3 as well, it will prefer the responses that were created by its own model, which is really important, right? Label correlation is a thing that happens when you as the human might look at your AI system's output and the evaluator that you created looks at the AI system's output, and you generally both agree that the result was pretty satisfying, right? But if you look under the hood, what you might realize is that when the LLM took documents from your database in order to book that particular car service, for example, it looked at one calendar entry, right? And the rest, it looked at, things that were completely irrelevant, right? Maybe emails from another customer and things like that. And so what you will get in that moment is the model that you use to generate the final result actually compensates for your retriever's lack of intelligence to select the right context. And therefore, you get a false positive, you think everything's fine. But once you release your system into the wild, there are going to be a number of questions that will come in that might have your model fall over. You think everything is peachy and everything is wonderful, but really users have a really bad experience, right? And then finally, test set leaks. These are things where you might have accidentally trained your model on publicly available test data, right? Specifically when it comes to solving math problems, that tends to be an issue, or coding problems, because a lot of the LLMs are trained on all the public GitHub repos that are out there at the moment. And so sometimes your LLM your evaluator might come back and say, yeah, your system really created great code, when really the code that it generated wasn't either original or maintainable. It just used, essentially was inspired by various GitHub repos that are out there, and the evaluator was inspired by those same ones. So, those two things agree, but an actual engineer that looked at the auto-generated code would go, no, we won't be able to use that. What a load of rubbish, right? That's something that can happen too. Excellent. So, these were the first two papers. We're almost at the end. There is a third set of papers that might be really worth looking into. So now that we've sort of talked about evaluation at a model level and at the use case level, you have a few things, that you have a few things to sort of control for when evaluating the models that are out there, so the big ones, and when you're working with systems you're building in order to make sure that they are working as expected. But we still haven't really solved one problem yet that would be really neat to solve for occasions when you are building your own AI-driven features or your own AI-driven products, right? And the thing that we haven't kind of figured out is that if you build an AI system, let's say you build a RAG system, right, and you can test it with RAGAS and it performs reliably enough, at least to a point where you're happy with it, right? There is nothing that tells you, or there's no scientific method that essentially tells you and says, well, the responses that you got, you might be happy with it. But if you used another model, right, it would have given you a much better response, one that sweeps your user straight off your feet, right? The moment there is no reliable mechanism or method that looks at your specific use case and your specific data, and then evaluates all the models that are out there and tells you which one fits your use case the best, right? Because as we've established, looking at some of the benchmarks that we've seen isn't necessarily reliable, right? Because sometimes LLMs tend to be trained on the specifically responses to some of those math Olympiad questions, right? And then the benchmark comes along and the LLM walks in and is like, yeah, someone gave me the answers earlier today. This is easy, right? Or those responses might be too, or the questions that you're evaluating the model against might be too generalized, right? And so wouldn't it be really nice if you were able to go ahead and evaluate a particular model or a particular solution that you have specifically against your use case, right? That way you don't need to worry about model level evaluations not being accurate for your use case. You know exactly what which model is the best, which LLM might be the best to solve your specific use case. And this is where generative benchmarking comes in. It's a really great blog post, really good read, a really easy read as well. So I would encourage you to check it out. And the core idea essentially behind it is that instead of relying on sort of like these pre-existing generic data sets that we use to test the various models, what you do is you create a custom benchmark for your use case. And the goal here is really to evaluate or have evaluation that's far more representative of what's actually happening in real production scenarios and what your users are really, really saying here, right? What's happening here is you have the system that takes a bunch of documents that you provide to the system, right? And it chunks them up. It then decides which chunks are relevant or not for you know, the particular use case that you or the particular queries that you're building. It filters them out relative to each other. And then it says, okay, based on this context, right, I'm going to ask an LLM, based on these filtered chunks and the documents, I'm going to ask an LLM what kind of queries I think I should be generating, right? It also can take some example queries that you might provide it with, right? And then it essentially spits out a long list of questions that you can go ahead and test your system with different LLM backends with, right? So it says, okay, here are 5,000 questions, right? For your AI system that you've just built, right? Ask those 5,000 questions to your AI system with OpenAI in the background, or with Gemini in the background, or with DeepSeek in the background, and see what comes back. And that way you get a benchmark of those various models that is very specific to your use case, which is really, really neat. The interesting part is that this is not just an academic exercise. There are tools out there right now, even though that paper only came out in the last 30 days, that allow you to do exactly that. Ragas, as I mentioned before, is one of these testing frameworks, has released a feature that allows you to just submit your documents. It's very, very easy. It's just a couple of lines of code that you can copy from the documentation page. And it will go ahead and create a knowledge graph of all the concepts that are represented in your documents, then complements that or enriches it with additional information that is available in the public domain, and then goes ahead and creates a number of test cases for you, right? That you can see here. And that makes testing a lot cheaper and a lot faster, because now you're not the one who has to come up with those 5,000 test queries, right? It is the system that does that for you, which tends to be really, really powerful. Really a good framework to have in the back of your pocket when you're talking about AI evaluation in businesses. And then finally, right, the last paper, and we're going to go through that really, really, really quickly, is FreshStack. It is the same goal, but a different approach, where the people who have done that research came up with a new concept where they said, okay, we're looking at a particular query, right? You can see here someone's asking about not understanding how a text splitter works. It goes out and creates a and looks at Stack Overflow for code, for example, right? picks the most prominent response, treats it as a ground truth, so to say, says, okay, so Stack Overflow believes this is the correct answer to this particular coding question. And then similarly goes out and creates a document corpus about that subject as well. And then takes the actual response that it received from Stack Overflow, right? And sort of nuggetizes it. And nuggetizing means that it uses an LLM to go and it's like, okay, look at the response, extract the key concepts and the key facts. And then finally, what it does is it takes each of those key facts, goes through the document corpus that it generated, and assigns a document to each of those key facts. And from there, it takes the top nugget document pairs and then sends that one final time to a LLM and says, okay, now given this core concept and the document that is associated with it, compare that against the response that your AI system generated and see how much this core concept and this document supports the response. And it does that, of course, hundreds and hundreds of times, and therefore generates a bespoke benchmark for your use case, given the data that applies to your business, specifically in the technical documentation use case, right? Sweet. The interesting part about this is that searching with these nuggets is better, or querying with these nuggets was found to be better than querying with the actual correct answer to the question, which I thought was really, really interesting because it just shows that the power of being really concise and really factual with LLMs, taking out the remaining fluff, even if it's just a couple of words, the power of doing that and how that affects the accuracy of your AI system overall. Sweet. So that was it. Again, as per usual, before we go to questions, couple of projects worthwhile checking out. If you're so inclined, we'll share these slides through Dylan. And if you have any questions, suggestions, ideas, concerns, let me know.
Thanks, Mike. Dylan, I've got to go.
Yeah.
But what a great session again, as ever. Love your work, Mike.
Thanks, Roger. Too kind.
I'd like to actually catch up with you before next month's session. A couple of things on my mind. So.
Will do. Would love to. Let's connect. Sounds great.
Thanks
Good stuff.
Cheers.
See you later,
everyone.
Roger. Bye.
Thanks, Roger. Take care. Right. Does anyone have any questions?
That was really full on. Sorry for me.
Hey, Mark, can I connect with you offline? I mean, because I think I need to hop off right now. Okay.
Yeah.
So thank you again, Mike. That was amazing. I probably have to watch it all over again to just absorb everything. You went into so much detail in such a, like, I would have never thought to evaluate it in this way or with these models are even available.
Yeah, no, absolutely. And I think, particularly, I believe, Em, as far as I can remember, you're particularly in the marketing space. Is that correct?
Yeah.
Yeah, exactly. So you are particularly taking advantage of tooling that does things like generating content, does things like making, determining, which content fits the best or what wording best to use, right? Tools that are publicly out there, if you're using secondhand tools, right, they should provide you with a detailed insight into how their systems and the system's reliability is tested. That is actually a really good measure to evaluate the various tools that are out there. But if you are finding yourself in a place where you're building these tools yourself, right, for reputational protection purposes and so forth, really using some use case specific evaluation, even if it's really lightweight, is absolutely critical, right? If you do that at scale, if you build something that puts out marketing copy without you even having to be in the loop, right? You want to make sure that the company is protected against that reputational damage that can come with a cheesecake confirmation email.
Thank you.
Excellent.
Until next month. Bye.
See you next month.
Thanks.
Bye. Excellent.
Anyone else want to jump in?
Good stuff. Well, if there are no further questions, was absolutely lovely hanging out with all of you today. Thank you so much, Dylan, again for this wonderful convening everyone in this wonderful group again. Really appreciate it. If you have any feedback, questions, suggestions, concerns, please don't hesitate to share it with Dylan, and then he will pass it on to me. But as always, it's a really wonderful experience to do that with you.